Hello. So I am going to be demonstrating the Hex Grid demonstration that I have just made. So I'll just start it up right here. I'm going to build. I don't need to rebuild, but it works just the same. All right, so as you can see at the center of this hex grid, or of this window, uh, is this hex grid, and when I move the mouse, it finds out which hex is getting highlighted and draws a hex there in blue. Now I can also change the value that represents what is referred to in code as the x and the y vectors. So I can change this to be 20, 5, and then this one to be, say, 10, 20. Oop. I didn't mean to do that. 10, 20. All right, and that will slightly distort the look of the hex grid. Now, if I uncomment this part, the x and the y values now have a very particular value in that. So x and y are a vector representing the center of this hex to this dot right here, and then y is that center to this dot right here. And those vectors go together to create A, which is the difference from this center point, from this point in the center of this hex to this point, which is basically plus 1A to it. And it's done in such a way that the A and the B vectors are exactly perpendicular. And then in order to retrieve the particular hex value that you're looking for, it does a particular type of projection that allows, okay, something go wrong? Something probably went wrong. There we go. So in essence, there's a projection onto A and onto B that is used to determine the distance from this center point to the hex in a sort of row column setup. So as an example, this would be, say, 0, 0. This would be 1, 0. This would be 0, 1, and then this would be 1, 1. So you could essentially combine this with a matrix, with like a two-dimensional array, and then use this hex grid to find out where to place it on the screen. So like if you had some sort of character like right here, and you wanted to move it to there, it could be done by any sort of arbitrary hex angle. But yeah, now it's the exact type of projection is like a normal is a normal scaled projection. So in essence, I find the normal of B and the normal of A, which is any vector that is multiplicate is the dot product, wherein the dot product is equal to 0 between A and the normal of A, so it's perpendicular. And then the normal projection, so the projection that P does, which is the center, which is the point minus the center, is scaled based on that, and it produces a projection where the rejection is exactly in the direction of the normal, the vector that the normal was taken from. So so as an example here, this is A and this is B, and 1, 1 would be and so the projection goes sort of in the direction of A, and then it projects it onto B, the vector going in this direction, where B, and in order to do that, you take basically A's normal, and then you use that the law of similar triangles to scale it so that the projection onto B plus the rejection is this, and the rejection goes in the exact same direction as A. So yeah. And that's basically what I've been doing.